Welcome back. Hi everyone. In this session, we will be discussing about virtual function and a pure virtual function in C++. Let's start. Virtual function. So if the function is declared as a virtual in a base class and always or must be redefined in the subclass. Such a function is going to be called as virtual function. You can ask me, sir, what is the need of virtual function? Again, the same thing. For example, in a project, in banking project or in a project, the function must be declared in that way. So that function can be declared in the base class. So the implementers or developers, they cannot name the function as they want. Instead, they'll be using the same function name which is defined in the base class. So it is used for the as the template. That function can be redefined or overridden in the subclass as they want, but the function signature must be the same, which is function name, prototype, everything must be the same, but definition alone differs. So that is the use of the virtual function. To define a virtual function, we should use the keyword virtual, and the virtual functions are generally used to implement the runtime polymorphism, and the base class pointer can be used to point the derived class function depending upon the need at the runtime. So let's see the syntax. So some rules of virtual function. So we must use the virtual keyword as a prefix, and it must be declared in the members of some class and redefined in the subclass. They can be a friend of the another class, and function prototype in the base and the derived class must be the same. And there is no virtual constructor, but virtual destructor is allowed. So these are all some rules of the virtual function. Let's see the syntax. So as I said, the virtual keyword, return type of the function, and function name, list of parameters, and definition. Okay, let's see the example of the virtual function. And my class name is shape. This is my base class. Shape is my base class. Virtual function is virtual keyword, and function return type, function name, and some definition. So end of the shape class. So virtual function always or must be redefined in the subclass, right? So here circle is my derived class. I'm inheriting the base class shape in a public mode, which means I'm going to redefine, I'm allowed to redefine the draw function in a circle class as I want, right? While redefining the same virtual function in the derived class, no need to use the virtual keyword. So virtual keyword is used to specify only in the base class. In the derived class, function name is void, draw, and return type is void, and definition differs over here. So that is the end of the circle class. Similarly, more than I'm having another class rectangle that also inherits the shape class, but in a public mode. Here it is also overriding means redefining the function. So though the void draw function is there in the base class, virtual function is it's a template, right? So in a derived class rectangle, draw function is again redefined. So depending upon their need, the developers can redefine the function as they want. So depending upon the requirement of the client, they can define as they want. Okay, so at the main function, what we are doing is we are going to create an object for the base class with the pointer. The pointer is going to be pointing the which derived class as they want at the runtime. So let's see main function. So here the object S is the base class object, derived class object C, and derived class object R. So circle and rectangle are the derived class object. So here I'm creating a base class pointer. So at the runtime, I'm changing the pointer to the derived class object C, which means circle class I'm pointing. I'm calling the draw function. Now the draw function is drawing the circle. Okay, after some time I wanted to switch over to some other function. I'm changing the pointer to the another class called R. R is belong to rectangle. So now ptr dot point, this is actually, if you're calling with a point variable, you should use this symbol pointing to draw. So this draw function is going to draw the rectangle draw, or call the rectangle draw function. So like this, any number of derived classes I can have. With the base class pointer, I can switch over to any derived class function as I want. So this is what called as runtime polymorphism, or dynamic binding, or late binding. Okay, so runtime polymorphism, virtual function is another name for the another way to implement runtime polymorphism, or it can be called technically late binding or dynamic binding, right? So I'm repeating. So base class pointer pointing to the derived class object. Similarly, base class pointer pointing to the some other derived class object and calling the draw function. So that is the dynamic binding. It is possible with the virtual function. So next topic, pure virtual function. So pure virtual function is if a virtual function doesn't have any definition, that is called as pure virtual function. It is only used for template. It is always implemented, going to be redefined in the subclass. So such a function is going to be called as pure virtual function. So it's a base class that has no definition in the base class, and it is always overridden in the derived class, and it's an empty function or it's a dummy function. So it provides the template, and the derived class can be implemented as they want. So that is what the pure virtual function. Let's say the syntax. Same way, so virtual keyword function name equal to 0. This is one way of declaring pure virtual function, or in another way you can define with the empty statement. So in both the way you can say that as a pure virtual function. If the virtual function doesn't have any definition or empty function or equated to 0, so that is going to be called as pure virtual function. I'm having the same example which we discussed in the virtual function. Same example, shape function virtual void draw. So here I equated to 0. In the previous example, we had a definition. We had a normal virtual function, we had a definition. But whereas in a pure virtual function, what I'm doing is I'm equating to 0. That is no definition. It's a dummy, it's a template. So it must be inherited, it must be overridden in the subclass or in the derived class. So class circle class is the derived class which is deriving the shape class. So draw function must be re-implemented or redefined here. Similarly, in a rectangle class, I'm inheriting the shape base class. I'm redefining the draw function. So coming to main function, so here what I'm doing is I'm creating the object for the respective classes and calling the respective definition. So here I'm not using base class pointer because nothing there in the base class. So that what I'm doing is here I'm creating the object for the derived class, respective derived class. I'm calling the respective draw function. So that is what the pure virtual function. If any class is having at least one virtual function, that class is going to be called as abstract base class. So that we will discuss in the next session. That's it about in this session. Thank you all.